Jai Shri Gurudev. Good morning, one and all. In the last class, we discussed about module 1 curved beams. What are beams? What are straight beams and curved beam? The difference between straight beam and curved beam. Then stresses in curved beam. Today, we are going to solve one problem related to a curved beam, that is the C frame. Now, determine the maximum tensile, compressive, and shear stress induced in a C frame of a hydraulic portable riveter as shown in the figure and also draw the stress distribution. Now we'll see the figure. First we know the what type of frame it is, C frame, and what type of cross section it is. When you pass an arbitrary cutting plane, it is a rectangular cross section of width is given 50 mm and height is given 80 mm, and center of curvature is R100, and the load is acting at this 9000 Newton. And from the line, this is a the line of action of load to the center of curvature is given 175 mm. Now see, whenever see the geometry or the figure, first identify the type of beam is a curved beam, then cross section, and then loading property. After that, now redraw the sketch. How to solve this problem? Redraw the sketch like this, the C frame, and also draw the below this the cross section. What type of cross section? Rectangular cross section, breadth and height, and draw this. Thus, the centroidal axis is the center of the geometry, and the neutral axis always lies towards the center of curvature, or it will be between the center of axis and the center line of curvature, right? Then show that when it is subject to load here 9000, this line shows the line of action of force, F, right? Now this is the center line of curvature, and then as when is subject to an external load here, it tries to bend like this, right? It tries to bend like this. Now above the neutral axis, the fiber undergoes compression. Below the neutral axis, the fiber undergoes tension. Once you redraw the cross section, where is the critical cross section here? The critical cross section is at this location only. The chord will start from here to here, but critical cross section takes place at this end when you subject to this load, right? Now redraw the cross section. Now this is again inner fiber. See the inner fiber, this is the outer fiber. Then inner fiber and outer fiber. Then write all the nomenclature from the center line of curvature at the inner fiber. This is RA, radius of inner fiber, radius of neutral axis, radius of the neutral axis, the radius of the central axis, and radius of the outer fiber. And the difference between the radius of the central axis and the neutral axis is the eccentricity. Then with respect to central axis, what we call is at inner fiber C1, C2, and with respect to that neutral axis, Ci and C0. And what is L? L is nothing but the distance between the line of action of force and the central axis of the cross section, critical section. Then you write the given data. What are the given data? From the sketch you can see that Ri is given 100 mm, R0 is 100 plus 80, that is H, and Ri plus H. Then force is given 9000 Newton. What type of cross section? Rectangular cross section. The section is, once is a rectangular cross section, its width is 50 mm, height is 80 mm. Now once you write the given data, now what are the other data are required? Other data are RC, Rn is unknown, right? Now to get RC by referring the table, other data by referring the table 2.7 is a property cross section. What type of cross section it is? For rectangular cross section. Now see the figure, rectangular cross section B and H. Now where is it? This is the inner fiber, the outer fiber, right? Then from from the inner fiber. This is distance is C, is the farthest point from your. This is what axis it is? Centroidal axis. Now BH is given. Now what is the area? In that table itself, we'll get area is going to be into H. We get substitute. We'll get 4000 mm square. Now distance of farthest point from C. What is C is indicated in that table 2.7 in the for rectangular cross section. From the inner fiber to the centroidal axis, distance between central axis and the inner fiber, C is equal to H by 2, that is 40. This is also equal to C1. Then as you know that RC, how to calculate RC is a RI plus C1. Then you substitute, you get the RC is 140 mm. Then C2, how to get C2? C2 is total H minus C or C1, that is get H minus C, that is get 40 mm. Now this is how do you get the RC value C1 and C2 from the table 2.7. Similarly, another data is Rn. How do you calculate Rn? Now refer the table 25.2 from volume 2 for rectangular cross section. The Rn is equal to, this is the formula, that is equation number 25.61. Or H we know that, R not I also know, Ri we know that. Now substitute, you get Rn. The radius of the neutral axis 136.103 mm. And verify it whether the answer is right or wrong. Always Rn it should be less than Rc, because neutral axis lies between central axis and the radius of curvature. Then calculate other data, Ci and C0 and eccentricity, right? Then after this, now what is the L is the distance between the line of action of force and the central axis of the critical section. We know the 175 plus 170 plus RC, that is the distance between the line of action of force and central axis. Then you'll get. Then after that, one more other data is bending moment. Due to the force applied here, this is eccentric load occurred on that section, that is directly transfer that load to the cross section. That is what in nature is tensile in nature. And force into distance, this force into distance, that produces what? Movement. Okay, then what is the external movement here? Due to the force, what is the movement occurred? Force into L. This is the force is once the movement is occurred. Next, now calculate our aim is to calculate the maximum tensile, compressive and shear stresses and its distribution, right? Now direct stress. What is direct stress? As you know that force by area. Then you'll get that's what in nature? Tensile in nature. Next, bending stresses at the inner fiber. The inner fibers are subjected to what? The inner fibers are subjected to tensile in nature. That's why the positive sign will come. What is formula? MB by A into Ci by Ri. Now substitute, you'll get again bending stress is this one. That's also in tensile in nature. Then bending stress outer fiber. What is outer fiber is? Outer fiber is subjected to what? Compressive nature. That's a negative sign comes here. MB by A into C naught by R naught. Now substitute, we'll get this value. Now what is the maximum tensile stress? Where is the maximum tensile stress is occurred here? The maximum tensile stress is occurred at the inner fiber. As you know that how to calculate maximum tensile stress, we know the combined stress is equal to direct stress plus bending stress. At inner fiber, that is sigma, we know the combined stress sigma is equal to sigma d plus sigma b. At inner fiber, direct stress plus bending stress in the fiber. Direct stress is positive, bending stress also positive. We substitute, this is the maximum bending stress occurred at inner fiber. Similarly, go for maximum compressive stress is at the outer fiber. Again, combined stress is equal to direct stress plus bending stress at outer fiber. When direct stress is positive, what is the bending stress at outer fiber is negative in nature. And substitute here, this is the maximum compressive stress. Then maximum shear stress, as you know that the shear stress, maximum stress is always half of the maximum normal stress. What is the maximum normal stress is? Here you get maximum normal stress is at the inner fiber. Now substitute, then you will get this equation. Now this is the stress distribution. And again redraw the section, inner fiber and outer fiber. central axis and neutral axis, always you plot the stress with respect to neutral axis. At neutral axis stresses are 0, right? First, direct stress in this section, direct stress, the tensile stress here due to external applied load is a constant throughout the section. Then comes to bending stresses. At neutral axis bending stress 0. At inner fiber bending stress is maximum, how much? 65.61. At out there is a tensile in nature, positive x direction. At outer fiber bending stress are compressive in nature, minus 44.35. Then how the stressor varies here is varies a non-linear. Then bending stress at now after the combined stresses, the inner fiber and outer fiber. Combined stress inner fiber is 67.911. Bending stress, there is a tensile nature. At outer fiber 42.103, that is compressive nature. How it stressor varies is non-linear. Thank you for watching this video. The remaining problems are there in the Dme-II textbooks. Try to solve those problems.